Hi, my name is Zoltan Kochan. In my presentation, I want to talk about package management in monorepos. I'll discuss some of the pain points and share recipes for effective package management in monorepos. Currently, I work at Bit, where I handle dependency management related tasks. I'm also the lead maintainer of the pnpm open source project, which is a JS package manager. Before Bit, I worked at JustAnswer. At JustAnswer, we had a huge monorepo with hundreds of components. Installation with npm took 30 minutes in that monorepo. That was the main reason I started contributing to a faster alternative, pnpm. With pnpm, we were able to reduce installation time to about 90 seconds at the time. Let's briefly talk about the history of monorepo tooling for JS projects. Babel was one of the most influential projects in the JavaScript ecosystem, and it was probably one of the first popular open source JS projects that used the monorepository. The creators of Babel have created Lerna in 2015, which was able to install dependencies in a monorepo using npm CLI under the hood. As that said, installation with Lerna was terribly slow, to say the least. Everyone knew that package managers should implement installation in monorepos out of the box. By 2017, both pnpm and Yarn have shipped monorepo support. Yarn has called this feature workspaces installation, while pnpm has used the singular term workspace. In a couple of years, npm had also shipped workspaces support. So as of today, there are 3 popular, mature Node.js package managers with built-in package monorepo support. There are 2 ways package managers can arrange dependencies in a monorepo: hoisted and isolated. All 3 package managers support both layouts. By default, Yarn and npm use a hoisted approach. With this approach, all direct and indirect dependencies are placed in the root node modules directory. If there are multiple versions of the same dependency, one of the versions gets nested. As you can see on the slide, there are 2 different versions of Lodash. So one of the versions is hoisted to the root of the monorepo, while the other one is nested inside app2. pnpm uses a different layout called isolated node modules. With the isolated node modules, the dependencies of every package are nested. The benefit of this approach is that packages only have access to their own dependencies, while with hoisted layout, all projects would have access to the cookie package. With an isolated node modules layout, projects have access only to their own dependencies. So in this case, only app1 will be able to require cookie. I think most people agree that monorepos provide a superior developer experience. Despite this, it's really easy to mess up dependencies in a monorepo. As you can see in this example, the app is using cookie, but doesn't list cookie in its dependencies. This code will work locally because cookie is found in a node modules directory of a parent directory. However, it will break when someone installs app1 outside of the monorepo. Another issue in this example is that main.js in app1 is using Lodash. Main.js is production code, but Lodash is listed in the dev dependencies. It means that this code will work locally, but will break in production, where dev dependencies are not installed. To catch these two specific issues, you may use a special rule in ESLint, the no extraneous dependencies rule from the import plugin. If you configure this linting rule, ESLint will notify you of dependencies that are imported but not declared in package.json. In this case, you'll get an error about cookie being used in app 1. ESLint will also notify you about Lodash being a dev dependency, even though it is used by production code. Working with peer dependencies in monorepos is challenging. It is crucial for the peer dependencies to be singletons during runtime. If possible, you should try to use a single version of the peer dependency across all the workspace packages. As you can see in this example, both card and button reference the same React version. This will work fine. Whether you're dealing with peer dependencies or not, it's preferable to use the same version of a dependency across all of your projects. Doing so can help you avoid issues related to peer dependencies and reduce the size of your packages. To the best of my knowledge, only Yarn currently supports syncing versions of dependencies out of the box using constraints. pnpm has plans to introduce this feature through workspace catalogs. It is also possible to use third-party tools for finding version duplicates. Multiple third-party tools act as linters to verify version inconsistency. One such tool is syncpack. In large monorepos, it can sometimes become challenging to avoid having multiple versions of a peer dependency. Among npm, yarn, and pnpm, only pnpm offers a feature to support multiple versions of a peer dependency. This feature is known as injected dependencies. When injected dependencies are enabled, workspace packages are copied, allowing them to run with different versions of the peer. As you can see in this example, the button component uses React version 17, but the card component uses React version 16. When we run tests for the button component, we aim to use React version 17. In contrast, when we run the button component from within the card component, we want the button to use the same version of React as the card. Therefore, React version 17 is installed in the node modules of button. Meanwhile, card doesn't reference the button directly from the workspace, but from a hidden subdirectory where it's aligned with React version 16. This setup means there are two instances of the button component in the workspace, one with React version 17 and another a copy inside the node modules.pnpm directory with React version 16. The only downside to this approach is that once you modify the button component, you need to rerun the install process so that pnpm can update the files of the button component inside the copied instances. After discussing the challenges associated with monorepos, I'd like to introduce another tool that addresses these issues out of the box. The name of the tool is Bit. While Bit is not a package manager, managing packages is one of its primary responsibilities. So, what exactly is Bit? It's a toolchain designed for building composable software. You can conceptualize it as an alternative to Git, GitHub, the npm registry, and various npm clients. When using Bit, it serves as your version control system, manages your dependencies, and publishes your packages. For this presentation, we'll focus solely on package management, so I'll discuss only the installation aspect of Bit. In many ways, a Bit workspace resembles a pnpm workspace. It's a collection of packages or components. However, there's a distinct difference. There are no package.json files in a Bit workspace. Instead, all dependencies for all components are declared in a single manifest located at the workspace's root. Moreover, there's no separate field for dev dependencies. This streamlined approach is feasible because Bit conducts a code analysis of the components within the workspace. It automatically identifies which components utilize which dependencies and discerns whether a particular dependency is for production or development for a given component. Let me show you now a quick demo of a Bit workspace. I will use VS Code and the Bit VS Code extension. As you can see, I have the Bit VS Code extension pre-installed here. I will go to the Bit section and start a new workspace by clicking on this button. Now I have a new Bit workspace initialized in my current working directory. In the file navigator, you see we have all these Bit related files. This is the workspace manifest. We don't have any dependencies yet. We don't have any components yet. Let's create some new components. I will use the bit create command for this. I will create two new Node.js components, app1 and app2. As you can see, we have all these two new folders, and we don't have package.json files for our components. As I said, Bit automatically generates package.json files on export of components. Let's go to the Bit view and let's add some new import statements to these components. I will add load-dash to app1. As you can see, load-dash is missing for now, and I will add lambda to app2. Now, if you would use a pnpm workspace, you would run something like pnpm filter app1, and you would add this load-dash to app1, and then you would run pnpm filter app2 and add lambda to the package.json of app2. With Bit, this is simpler. You just need to run bit install add missing deps. Bit will perform code analysis on all the components. It will find all import statements, and it will install any missing dependencies. under the hood it will run pnpm to install the dependencies. As you can see, Lodash and Lambda were added. You can see that Lodash and Lambda are now in the root node modules. We don't have the missing dependency error anymore. And you can see these dependencies are now in the dependencies in workspace JSON-C. So we don't have package.json files, but Bit has all the necessary information for a package that you would see in a package.json file. Just click on the component details here, and there's the dependencies section here, and you can see that Bit knows that app1 uses Lodash as a prod dependency. And in the details of app2, you can see Lambda in the prod dependencies too. Let's commit these changes. I use Bit for version control in this workspace. If you wish, you can use Bit with Git. That's not an issue. So you can use Git for version control and Bit for package management, or you can use Bit for both. Now you will move these import statements in app1 to a test file. And this means that Lodash is now just a dev dependency. Now, if you would use pnpm, you would now have to modify package.json and move Lodash to dev dependencies. You might as well forget to do this, and in this case you will continue publishing your package with Lodash in prod dependencies. However, with Bit, nothing should be done. So if you click on the component details, you can see that Lodash is not in prod dependencies anymore, it's in dev dependencies. Let's remove Lambda altogether from app2, and as you can see, now Lambda is not in any dependencies of app2. If you would use npm or pnpm, you would have to check all files of app2 and verify that none of the files are importing Lambda anymore, and only after that you would remove manually or with the command Lambda from the dependencies. With Bit, this is a simple one-line change, and everything else is done automatically. We can go to the source control tab and see that Bit also shows you changed dependencies. So on app1 you can see that Lodash was changed from runtime to dev. Runtime is basically prod, and you can see that app2 doesn't have Lambda in any dependencies now. And that's it. In addition to managing dependencies, Bit also handles the compilation of packages within the workspace. This makes it considerably easier to support multiple versions of a peer dependency in contrast to pnpm. As illustrated on this slide, our workspace contains 4 components: 2 pages, a button, and a card. We want to use 2 versions of React in this workspace, so Bit creates 2 separate runtime environments for the components. One with React version 16 and another one with React version 17. Components relying on React version 16 are loaded from the corresponding environment along with all of their dependencies. Likewise, components that rely on React version 17 will be loaded from the other environment. All of their dependencies will use React version 17. Should there be any changes to a component, Bit will seamlessly update that component across all environments. Allow me to demonstrate how Bit allows multiple peer dependencies to be used in a single workspace. As you can see here in this workspace, we have the 4 components: page 1, page 2, card, and button. If we look at the component details, we can see that page 1 has a card in dependencies, and it has React version 16 in dependencies, while page 2 has card in dependencies as well, but it has React version 17 in dependencies. And card has button in dependencies and React version 17. When you run bit install, bit creates this subdirectory inside node modules called .bit_roots. And here you can see that we have these 2 directories, React 16 and React 17. So basically bit creates a subdirectory for every environment used in the workspace. The React 16 environment and the React 17 both have all the components copied to their node modules directory. The only difference is that the components inside React 16 will resolve React from version 16. As you can see here, there is also a React dependency, and its version is 16. So all these components here will use this React from here, the same version, which is 16. At the same time, in this directory there is no React folder, so Node.js resolution algorithm will look for React in parent directories, and it will find it here in this root node modules, and this one is React version 17. So when components will run from this directory, they will resolve React from here. So they will use version 17 of React. So this way you are able to run your components either with React 16 or with React 17 in this workspace. Like for instance, if you want to run page 1 with React 16, you just run page 1 from here, and it will run all its component dependencies from the same environment, and they all will use the same React version from here, which is 16. And if you want to run page 2, for instance, with React 17, you just run it from here. It will load all its dependencies from here, and it will use React 17 from the root of the workspace, because it's deduplicated to the root of the workspace. And obviously, if you will do any modifications to these components, the changes will automatically persist to these environment directories. This concludes my presentation. Thank you for the opportunity to speak with you today. I hope you were able to learn something new about monorepos today and the tools for monorepos. And maybe you'll give a bit a try. Have a good day.
Thank you, Zoltan. It seems that Bit is really a great tool to consider using. So now let's have questions to Zoltan. Guys, I have Zoltan here, so please write your questions in Discord chat. I'll be able to read them to Zoltan. Also, I would like to ask everybody to write in the Discord chat whether you use monorepo or polyrepo. It is very interesting to me, and I believe to Zoltan as well. So while we are waiting for your questions, I'll ask my first question to Zoltan. Could you please give a piece of advice whether a team is wondering when they should move from polyrepo to monorepo? What are the main advantages of monorepo, and when the team should actually decide to move from polyrepo to monorepo?
Actually, I didn't meet a lot of teams that use polyrepo. It's really hard to manage because you need to somehow configure all the different monorepos, basically copy pasting a lot of configuration, and you need to synchronize that. Someone does some automation around that, but to put it simple, monorepo is a bit easier because you need to configure just one repository instead of configuring multiple repositories. So I guess well, both approaches work, but maybe a polyrepo requires more in-house inventions because there are less well-known recipes and tools for managing polyrepos well. And for monorepos, there are a lot of ready solutions. So at some point, it might be easier to move to a monorepo or to have just like 2-3 monorepos for different areas. Yeah, so actually you don't really need to have one huge monorepo for everything, but you can have like 2-3 at the organization. Or you could actually have one monorepo and a few smaller repos. It all depends.
Thank you. And what are the most common misconceptions of monorepos? When does a team can understand that they actually use monorepo approach, not a huge monolith or God repo approach, something like that?
Oh yeah, so inside the monorepo, everything can be still divided into microservices or components. Monorepo doesn't mean that you have a single project that handles everything. You can still have isolation and these benefits of a polyrepo. What is interesting with Bit is that it's kind of dynamic, so you have a registry of components, and when you work on some feature, you can fetch all those components that you currently work on. So you kind of have a dynamic repository, which we call a workspace. And actually, this is something similar to what big companies use, as far as I know, like Google and Facebook. They have created similar tools in-house. They are not available to the public, but we know that they do this. They use this huge monorepo approach, but with some custom toolings that make it easier to work with.
Okay, thank you. We have a question in the chat from Leonid Kuznetsov. We have two monorepos, Lerna and NX. Both use pnpm, but we have issues with links. If we need link package from monorepo 1 to package in monorepo 2, we have issues. It does not work. We can use only hard link. Soft links not work. With Yarn, we did not have before this issue. Could you please explain how we should work with pnpm in this case?
So it's I don't have enough info about this, but some common mistakes could be that you have peer dependencies, and in this case, if you have peer dependencies, you need to make sure that you also symlink the peer dependencies to the target repository. So if, for instance, you want to symlink your components from the Lerna monorepo to the NX monorepo, then you also need to symlink actually React from the node modules of the Lerna monorepo to NX. And actually, currently, this doesn't work with pnpm out of the box, so we don't really have, we are not able to symlink all the projects from one workspace to another. We can only symlink a single one with the link command. We really should add a recursive like flag to it, and also a flag like include peers. For Bit, I actually implemented this. So with Bit workspaces, this works. But to pnpm, I'll have to add this. And why with Yarn it works, I don't know. I guess use Yarn then and report an issue to pnpm, and we'll try to help you.
Thank you for the answer. And we have one more comment from Leonid. Also, we have issues with the case when we need to work in the watch mode and rebuild packages. So he didn't specify actually what issues they have. So do you want to comment on this?
Rebuild packages on watch mode. He means after install. I'm not sure. Yeah, pnpm. I don't think like npm, pnpm, and Yarn work perfectly with these watch tools, because these are separate tools without integration. Maybe if the tools try hard to support package managers, it could work. With Bit, this is a bit easier because Bit is like an orchestrator, so it has both it handles both package management and the compilation. So actually, even you have like a watch command running in one terminal, and if you install new dependencies in another terminal, the watch command can automatically track down the new dependencies and restart the right components. I don't know all the details because I don't work in this aspect of Bit, but I know it works. And that's all. Yeah, so if they use the injected dependencies feature of pnpm that helps to support build dependencies, that might be the issue with watch commands too, because after modifying the projects in the workspace, they need to run install for install to copy the new files to node modules, and maybe that's why it breaks. If you have issues, you can also ask in Discord of pnpm.
Okay, and also after this online session, Leonid, you can move to voice chat with Zoltan and discuss this issue in voice. So maybe it will be better. It will be better to explain what issues you have and get direct answers. And we have still several more minutes before the break. So, guys, if you have other questions, please write them down. And while we are waiting, I have one more question to you, Dalton. Actually, is Bit itself developed with the use of Bit?
Yeah, that's a good question. These meta tools, they always have a point when the meta tool itself starts to use itself. We are not there yet. We are partially there. We have the web interface. Bit is like a GitHub alternative, and it has all this code reviews on the web and component exploration, navigation in the web, and discussions on the website. So all this web stuff is developed on Bit 100%. And like the VS Code extension, I believe, yes, also. The Bit CLI tool, which you run in your terminal when you develop locally, it is not on Bit yet, only partially. Partially on Bit. We build it with Bit, we run tests with Bit, we install dependencies with Bit, but we don't use the Bit version control system, so it's still hosted on GitHub. Yeah, so it's we're in the process.
Very interesting. Thank you. And probably the last question, is Bit as a package manager backward compatible with npm or pnpm or other tools?
So partially, yes, because we use the same registry API. We use the same package.json format, so you can actually publish components, Bit components to the npm registry, and then you can install those components with those packages with npm or with pnpm or with Yarn. So you don't need to use Bit to use those packages from the Bit registry or from the registry, the target registry to which you published. What is not compatible is the Bit workspace. So you can't run just npm install in a bit workspace. It won't install the dependencies because it doesn't contain any package.json files. So under the hood, bit actually runs Yarn or pnpm by default, but it runs it through API and it sends it packages on files created in memory.
Very interesting. Thank you. So we don't have any other questions in the chat, and our time has run out. Thank you so much, Zoltan, for such useful topic. It is really interesting, and I think a lot of colleagues will consider using Bit or other tools for monorepos. So, guys, we'll meet in an hour. Now we have a lunch break, and you can ask questions now in voice chat. You see that Zoltan will be there. You can ask questions there by the voice and discuss in more details all the around topic. So just consider using it. Thank you so much, Zoltan.
Thank you, Anna. See you.